Last evening, I left you with a promise. I will see you again in the morning. It is exactly 6 a.m. We have returned to the Brihadeeswara Temple in Tanjavur. But strip away the centuries of myth. Strip away the tourist brochures. We are not here today merely as devotees, not as casual travelers. Step into a 1,000-year-old engineering machine, a colossal monument forged from the granite, locked by gravity, guided by geometry, and amplified by sound. This is a masterclass of ancient India speaking directly to us through the stone. Welcome back to Nomad Echoes, the intersection where travel meets physics, where history collides with mathematics, and where civilization is decoded through science. Let us look at the canvas built by Rajaraja Chola I around 1010 CE. This massive 44.6-acre complex is a masterclass in strict axial planning and a grid architecture. Look at the inner scantum's footprint, a precise geometric rectangle measuring exactly 240.79 meters east-west by 121.92 meters north-south. The area calculated will be approximately 29,361 square meter, nearly 7.25 acres of planned stone geometry, Chola mathematics written directly onto the earth. Rising from this foundation is the Vimana, the great central tower piercing the sky at 66 meters, the height of a modern 20-story building. This is pure stone compression engineering, mass stacked upon mass. The granite has an unrelenting density of approximately 2,700 kilograms per cubic meter. Think about that. A single cubic meter block of this stone weighs 2.7 tons. And if you take a standard block of 2 meters by 1 meter by 1 meter, then the mass amounts to be 5,400 kilogram. That is 5.4 tons of dead weight in just one block. Conservatively, the total granite mass compiled here reaches up to 150,000 tons. Let us convert this into the true language of physics, the force. Using the equation, weight is equal to mg. The calculation comes to 1.47 into 10 to the power 9 Newton. 1.47 billion newtons of force. This temple isn't just built, it is aggressively locking itself into the crust of the earth, utilizing gravity not as an architectural enemy, but as its primary binding force. Here lies the first great paradox. There are no quarries nearby. Every single gram of granite stone was transported from 50 to 70 kilometers away without diesel engines or hydraulic cranes, relying entirely on a terrifying logistics network of wooden rollers, ropes, elephants, and human teams. The ultimate test of the system sits on a very crown, an 80-ton solid granite capstone. That is 80,000 kilograms exerting a massive downward gravitational force of 784,000 newtons. Now, how do you lift the 80-ton block to a height of a 20-story building without a modern crane? It requires immense, impossible expenditure of pure work. Look at the equation of the work, and inputting the values, we get around 51.7 megajoules of energy. To conquer this physics problem, the Chola engineers rewrote the equation. They didn't fight the vertical height, they traded height for the distance by constructing a massive inclined ramp. Imagine the ramp stretching 6 kilometers. Let us look at the trigonometry of this incline. You get an angle of 0.63 degrees. By extending the distance, they achieve a massive mechanical advantage. Now, mechanical advantage, you can see it's the ramp length by height. Inputting the values, again, you get the advantage close to 91. This ramp reduces the ideal pulling force by 91 times, dropping the vertical weight from 784,000 newtons to just 8,650 newtons. Ideal physics exists only in paper. In real world, friction is also a villain. Calculating the brutal resistive force fighting against the workforce. You can see here, using the equation for the force of friction, mu mg cos theta, inputting the values, we get here 78,400 Newton. When you combine the ideal pulling force with the force of friction, the total practical force required shifts significantly. That is equal to pulling 8.8 tons of force along that incline. If a team of 200 coordinated workers pulled simultaneously, each individual would need to exert around 435 newtons of force. That equates to 44 kilograms of force per person. Demanding, but entirely possible with coordinated human power, elephants, and bullocks. What if they had shortened the ramp by 1 kilometer? The angle jumps to 3.8 degrees. Mechanical advantage drops to 15, and the pulling force spikes drastically. Chola genius was their commitment to the distance, transforming a towering height into a manageable length. Observe the profile of the Vimana. By tapering the tower and keeping the widest mass at the bottom, Chola engineers lowered the center of mass and minimized the overturning moment. The geometry guarantees a line of action of the temple's weight stays safely within its footprint, preventing toppling. Use the formula moment is equal to force into height. If a severe storm exerts force near the top peak at 66 meters, even a moderate wind force produces an enormous turning effect on the foundation. Yet, the big temple stands completely unmoved because of its massive base and low center of gravity. Tanjavur faces an intense heat, which regularly hits between 38 to 40 degrees Celsius. At the moment you step inside the stone corridors, the air temperature drops dramatically. This shift is driven by the laws of thermal mass and thermodynamics. Granite has a specific heat capacity of approximately 790 joules per kilogram per Kelvin. Using the equation Q is equal to mc delta T, where C is the specific heat, inputting the values, you get 790 million joules of energy just to alter the temperature of a small fraction of this temple by one single degree. This massive thermal inertia means the interior absorbs heat slowly during the day and releases it slowly at the night. But thermal variation also introduces another problem, that is thermal expansion. And granite expands with heat. Using the formula for linear expansion, you can see the change in length will be coefficient of linear expansion times the original length times the change in temperature. Using the values, you see here the structural shift comes to 2.4 millimeters. If the builders had ignored this fractional shifts, internal stresses would have shattered the structure centuries ago. The flawless survival of the temple proves that its dry stone joints and load paths were designed to absorb and distribute thermal movement seamlessly. Listen closely to the sound design of the corridors. When chants occur inside these granite spaces, acoustics dominate. With the speed of the sound in the air hovering around 343 meters per second, a wave traveling 20 meters to a wall and returning back covers a total distance of 40 meters. You can see the time delay is set to 0.117 seconds. This delay creates a precise, rich reverberation. The stone surfaces reflect the sound waves while the carved pillars scatter them, naturally amplifying and sustaining the chants through the architectural design alone. Then there is the light. The temple tracks the sun oriented directly towards the east. At sunrise, the solar elevation angle theta is low at 10 degrees. The shadow cast by 66-meter tower stretches along the landscape. Using the trigonometric ratios and calculation shows that as the sun climbs to 30 degrees, the shadow shortens to 114 meters. By midday, at 60 degrees, it contracts to 38 meters. The popular myth claims that temperature casts no shadows. Physics, however, dictates that every opaque object in the path of the light must cast one. The true wonder is not magical absence of shadows, but the deliberate layout of the wide courtyard and the tower geometry. Today, we rely on CAD software and cranes. The Cholas relied on empirical observation, geometry, and material memory, carving their calculations permanently into stone. Surviving a millennium of weathering, the temple's endurance formula is beautiful, simple, immense mass, a low center of gravity, symmetry, and a brutal durability of granite. Trends change, but gravity never goes out of style. Thank you for joining me on the Nomad Echoes. And if this video made you see this ancient wonder through the lens of physics, please like, share, and subscribe. Tell me in the comments which monument should we decode the next. And until our next journey, keep traveling, keep questioning, and keep listening to the echoes of civilizations. Thank you.